Hello, in this video we're going to talk about discrete time models. So to motivate this talk, let's consider the sequence 1, 2, 4, 8, 16, 32, and so forth. So this is a sequence because it's simply a list of numbers. It is infinite. Notice the 3 dots at the end. This keeps going forever. Now we will denote the terms in the sequence with a variable and a subscript. So for example, the first term in the sequence will denote that as x sub 1. The next term in the sequence will denote x sub 2. The third term will denote x sub 3, and we continue this pattern x sub 4, x sub 5, and x sub 6. So for example, in this particular sequence, we could say that x sub 5 equals 16. And all that means is that the fifth term is 16, or the fifth number in our list has a value of 16. Okay, so a couple of definitions. The variable x is called the state variable. Okay, so if we were modeling maybe a population of fish, we start off with 1 fish and then we have 2 and then 4, and so forth. X would represent the number of fish. It represents the state of our system. And the notation x sub t, so this is read x sub t because that's a subscript. This notation denotes the state variable at time t. Okay, so now I want to define what's meant by a recurrence relation. So a recurrence relation describes the state of the system, so it describes x sub t in terms of previous states. Okay, so I'm going to describe x sub t in terms of previous states. Previous states could be things like x sub t minus 1, or maybe t minus 2, or way back in time, doesn't matter. So somehow in previous states and or t. Okay, so let's take a look at an example. Suppose a population of fish follows the sequence 1, 2, 4, 8, 16, 32, and so forth. Find a model for this population. Okay, so we're going to start off and say at time 0, the start of our simulation or the start of the experiment, we have 1 fish. Now the question is, how can you predict the state of the system, or how can you predict how many fish you have at time t based on previous time steps? So what's the pattern here? How do we go from 1 to 2, or 2 to 4, or 4 to 8? How do we predict the future as a result of the past? Well, if we look at the pattern here, it looks like we're always multiplying by 2. So we could say x sub t equals 2 times x sub t minus 1. Okay, and that would be a recurrence relation for this particular system. Now sometimes we are actually given the recurrence relation. So suppose we are given that x naught equals 10 and x sub t equals t minus 1 plus t. Find x1, x2, and x3. So sometimes we're given the formula and they want to know what are the first couple of terms in the sequence. Okay, so let's take a look at how we would do this. I really recommend a table. So I'm going to make a table of values. For the first column, I'm going to let that be called t, and in my second column, this is going to be x sub t. Okay. So first of all, when time is 0, we know that x sub 0 is 10, and that's given in the problem. Okay, next, I want to know what's going on at time equals 1. Well, x sub 1 equals, let's use our formula. Our formula says that to find the population or the state variable at time t, we take the previous value and add t. So I'm going to take x sub 0 plus t, in this case is 1. Well, I know what is x sub 0, that's 10, plus 1, that gives me 11. Okay, let's look at time 2. To find x sub 2, I take the previous value of x sub 1. I'm going to add t, in this case is 2. Let's see, the previous value, x sub 1, is 11 plus 2, that equals 13. Let's do 2 more just to make sure that we're comfortable here. So x sub 3 would be x sub 2 plus 3. That results in a 13 plus 3 is 16. And lastly, x sub 4 is x sub 3 plus 4. And that results in 16 plus 4 is 20. Okay, let's do another example. So in this example, suppose that x naught is 3. Suppose that x1 equals 5, and furthermore, suppose that x sub t equals x sub t minus 1 minus x sub t minus 2 plus 1 all squared. Again, I recommend making a table. You might want to pause the video and try this one yourself. Okay, so I filled in a couple of values for us. When time is 0, x sub 0 equals 3. When time equals 1, x sub 1 equals 5, and those quantities were given to us. When time equals 2, according to the formula, x sub 2 equals x sub 1 minus x naught plus 1 all squared. So let's work out what this is. X sub 1 is 5 minus x naught is 3 plus 1 squared, 11. Okay, let's do one more. X sub 3 equals x sub 2 minus x sub 1 plus 1 squared. So according to the table, x sub 2 is negative 11 minus x sub 1, which is 5, plus 1 squared. Okay, so this is negative 11 minus 36. That's negative 47.